we have our protective bed on the actual printer itself. This is so you can, I actually don't know why that's a thing, but it is pretty useful because it allows you to take the materials off, and then you don't have to do all sorts of installing when you have to clean it. So an important thing to make sure of before you start a print, so you want to make sure the bed's clear of all the debris, like leftover residue from the previous print. So this line here is actually a test line that the printer does before it actually starts your print. So I'm just gonna if you have extra material, what you can do is you can just kind of get your nail under there, and it'll, for the most part, it'll just fall off like that. Sometimes you have to pull a little bit harder, but usually you shouldn't have to do too much. So the next step before putting the bed back on for your print is you actually want to wipe it down. So we use isopropyl alcohol. This is a 70%. Some places suggest 90%, but this is shown to work for us. So you get your cloth a little damp, and then you give it a nice thorough rub down across. I like to do the whole board just to help it stay consistent. But if you just have a small print, you can probably get away with just wiping down the test area and the area of the board that you're attempting to use. And so what this ends up doing is it gets all the dust off. It gets all the extra little residues that get caught up from previous prints and stuff. So it's going to dry off here in a second. And another thing you want to make sure is that you only clean it when the board is at least cooled off a little bit. You want to do it as close to room temperature as possible. Or at least, because I'm not entirely sure why that happens, but that's what I've seen in suggestions, because it can affect the actual protective layer on the board. So when putting the board back in, it's important to know that this is heavily calibrated machinery. So when you put the board back in, if you want everything to be where it's supposed to be, you want to make sure everything's lined up. So you push the board. You want the board all the way back. There's 2 pins on either side on the back, and you want to make sure it rests up right against both pins in the little corners on the end. And then once you have it lined up there, you want to make sure it's flush on both sides, so that you have a nice smooth flat flush right here. And then this board is ready to go. So first off, we have to go into our CAD program. We're going to open up our file. I use PTC's CREO Parametric. It's a comprehensive CADing program that you might find out in the real world. And there's a free student edition that you can get online. So here I have for you just a small test part. We're going to open it up. And here we have it. As you can see, it's kind of here. I don't know what to say there. But we're going to refocus to the center just to make it easier to look at. So for putting it into the 3D printer, we need to make sure we save it as an STL file. So we go in, we want to save a copy of it, and then we scroll down here and make sure that we're using this STL file, stereolithography file. And for this particular program, you want to customize the export, because that's fine. Here, I'll back that up. I'll change the name too. Let's test 1. So, all right. So we want to make sure that we customize the export, because in situations like this where we have nice smooth curves, when you go with just the baseline STL that it gives you, you actually get these breakdowns where it runs in triangles and hexagons and the like. So you have these hard edges. So if you need a smoother surface, you can go in and change that here. So we're going to do a small reduction first, just to kind of see where it goes. And as you can see, it's gotten a little smoother. It's added in more angles here. And that's the chord height that we're changing to make sure to get those angles a little tighter. And then we're going to actually do a magnitude change here to get a nice smooth curve on the whole thing. And then now we have this very tight curve structure. You don't need to do this for everything, just when you really need to have a very circular object. So we're going to hit OK, and now the file is saved. So we can go to our File Explorer, and now we have this new print, test1. And then it's going to show up as a 3D object. If you go on to websites like Thingiverse and the like, you can download 3D object files that you'll be able to take directly over to the Slicer program. So since I don't have Slicer on my computer, I'm going to have to transfer it using just using my flash drive. So we come here, and then I'm just going to load it over into my project folder. And alright, going to double check that it's there. Cool, we have test1, and then we're going to eject. Alright, so that's it for this computer. When loading programs onto a 3D printer, you're also going to need to use a Slicer program to get a G-code file. And it's the G-code file that you actually end up loading onto the 3D printer itself. So first, so on the computers in the lab, we have Slicer PE, which is actually the program developed by the people who made the 3D printers. So once it's opened up here, we can see this this is identical to the board that we have. And when the important things to note over in the corner here is we want to make sure that we have all our settings correct. So there's actually a lot going on with this particular one that is not correct. So we actually use the 0.2 millimeter nozzles, and you can do you can do that in two different ways. You can do a speed print or a quality print. In my experience, there's not a big time difference between speed or quality, so you can get away with just leaving it on quality all the time. And then our filament itself is actually also incorrect. So we found that the Prusament PLA is actually functional, has all the settings that we need for the actual filament that we use in the lab. We use inland PLA filament, and it handles, I guess, exactly the same as the Prusament PLA. So you can feel comfortable in using these settings. And then we also want to make sure our actual printer is correct. So we have the original Prusa i3 Mark III. And then we come down to, this is an important thing to note when setting up your G-code files, is the fill density. So that's going to be how much filament it decides to lay down in the filler layers, the layers between walls and curves. So for the most part, you really only are going to need 10 to 15%. Especially if you're making thicker objects, you really want to stick to the low as possible. But I have noticed issues with making smaller items. You actually might need to go up to like 20 or 25%, because it can, when it's laying down the material, if there's not enough material to lay on top of, it can cause errors as you're laying it down. But for this one, we're going to just stick to the 15% because it's held up on this. So now I'm going to load in my 3D object file. So I go into here, and then I have my test1 object from the other computer, and I'm throwing it into my project folder on this computer. And I'm going to minimize that for now. So when to add in your object, you're going to just go over to this opposite corner over here, just hit add, and then here at the top we have our test file. And alright, so now our test object has loaded onto the platform. So this last tab on the right in the settings side, is the support material. The support material comes up as it's very useful in situations like this, where there's actually gaps between the platform and the object you're trying to print. So what you have to do is have it build in the support material. With the support material, you have two different options. You have everywhere or support on build plate only. And then when you do initialize support material, it's going to ask you to detect bridging parameters, which you definitely want to do, so that way it knows when to add support material and when not. There's some customization that you can do later in that, but I found for most everything I've had to print, I haven't had to change those, so I just hit yes, and here it would be ready to go. Another thing you can do with the settings is kind of a useful area to know about. You go in. So you right click on the object and it'll give you these options. You can rotate the object, so we're going to rotate it around the x-axis to prop it up, and then now on the platform we have our test object in a standing position. So like I was saying before about the support material, if you were to put the support material everywhere, it would actually build support material around the object itself on the sides here and here, so that way when it got up to these letters, there would be space filled in here. You want to avoid that as much as possible, because once you have the object printed out, there will be a lot of excess material that you'll then have to shave off with either an X-Acto knife or some other tool, or just sandpaper in some cases once you get down to just the last couple layers. So we're going to rotate that back down to lay flat. So we're going to go backwards to -90. Alright, so it's nice and flat on there again. I'm going to switch back to support on build plate only. And then we hit the export G code. And then it's going to give you a nice tidy file name. It's going to keep the object name from before. It's going to tell you the size of the nozzle. It's going to tell you the material you used. And then it's going to tell you the printer you used. So we're going to save that here. Alright. And then now we have to upload it to one more place before it starts printing. So we're going to go into our online platform URL posted here with the login information on the sheet. So once you're logged in, there's some updates. We should let the professionals do the updates, so that way we don't have any mix-ups in terms of the firmware syncing up to the software end of things. So we're going to ignore that for now. So here's our main page. Got the login. You have a temperature monitor, an actual live feed on camera, and there's some other tools in here. Don't really need those right now. But it's good to know they're there. But what you need just to get your first print done is you'll need to go down to upload, and then we have our little test print G code from before, and we're going to open that up, and then it's saving, and it'll pop up at the top here. So now we have our test print here and ready to go, and after that all you need to do is press load and print. So now that we've got our code uploaded and sent to our printer, for this particular printer, there are some other firmware updates that might need to be done on that, but we're going to let the professionals handle that. So all you have to do to get this to go away is you just hit this center button here, just one single click, and then now the bed's going to preheat. And once it's done preheating, it'll start your print. We now have waited for the bed itself to cool down. So on the actual info screen, we have two sets of temperatures here. The top one is the actual temperature of the nozzle, while the bottom one is the temperature of the bed. Once it gets down to in the lower 30s, you feel free to take it off, but before that you really don't want to touch it because the degrees are in Celsius. So anything that's going on there is very hot when it's in the actual printing mode. So to take it off, just like before when we cleaned it, you want to stick your fingers on the tabs here and pull up on it. And then so now we have our plate. And to remove the print, it is good to give it a little bend first, because sometimes it'll just pop off on its own. And in this case it didn't, but once I get there, just a little bit of torque and almost everything came off in the one go. So I'm going to put that here for now, throw that out later. And then, so as we had before when we started, we did end up with this little tab, but I'm going to go ahead and take it off because really you should clean them before and after you print. Here we have our print itself, and here on the bottom we have this little support material that I was talking about before when I was setting up the code for it. And for the most part it should come off. You gotta I guess this one, sometimes there's a lot of surface area and you gotta pull hard on it. And this isn't completely free of debris after pulling on it, but it will, just pulling on it will get most of it off, and then you'll want to go at it later with file or sandpaper. Just a couple quick troubleshooting things. For the most part, if you have a print that starts to run into issues, you should cancel it using the software from the other side. There's a big cancel button or pause button that'll allow it to stop. The reason you'd want to stop your print is when it starts to once it's missed its mark, when it's laying down a layer, you'll see like it start to flare off and there's just string, like this plastic string hanging off everywhere. So when that happens, you'll want to stop it as soon as possible. And so again, do that from the computer if you can. If for whatever reason you can't, or it's just failing to respond from that end, all you got to do is press this little X button right here at the bottom, and that actually resets the whole printer. And that's really why we don't want to do that on a regular basis, because it does reset the whole printer and that can throw it out of alignment with too many successive runs of that. And so another thing, if you do have to end up canceling a print, it'll shut everything down, and this will the actual print head will stop in place. So a quick little trick to take care of that is you can actually hold down this button, the acknowledgement button from before, and it'll bring up this little menu, and it'll allow you to adjust the print head height, and so that way you can raise it off the platform, so when you're clearing it of debris, you don't accidentally bump the printer head. And then to get out of this menu, you just hit the OK button again.